Welcome to The Explainer. Today, we're going to demystify the hidden rulebook that makes the entire internet possible. We're talking about the OSI model.
I mean, have you ever really stopped to think about what happens when you hit send? It feels like magic, right? Just instant. But what's actually going on is this incredible, super fast journey through a 7-layer process. That's what turns your click into a conversation halfway across the globe. So to really get why we even need a process like this, we've got to jump in a time machine. Let's go way back to the early days of computing, a time I like to call the Wild West of networking. Okay, so picture this, a world where all the big tech giants, we're talking IBM, Apple, Cisco, they all spoke completely different digital languages. I mean, they were building their own networking gear, using their own secret protocols, sometimes even their own special cables. It was, and I'm not exaggerating, total chaos. And what you ended up with was basically a digital Tower of Babel. If you decided to build a network, well, you were stuck with one vendor. That's it, because nothing else would work with it. If you tried to connect different systems, you had to use these clunky things called gateways that caused massive traffic jams on your network. And troubleshooting? Forget about it. It was an absolute nightmare. So yeah, it became super obvious, really fast, that the industry needed a common standard, a universal language that all these different devices could speak. And that, right there, is where the OSI model enters the picture. The International Organization for Standardization, you'll see it called the ISO, they came up with this model to be the blueprint for everyone. And the idea was pure genius, really. They took this unbelievably complex job of network communication and broke it down into 7 distinct, manageable, standardized layers. And here they are, these 7 layers. We start at the top, layer 7, the application layer. That's the one that's closest to you, the person actually using the computer. And then we work our way all the way down to layer 1, the physical layer. We're talking the literal wires and cables carrying the signals. And the key thing to remember is that every single layer has its own very specific job to do.
Okay, I know what you're thinking. That looks like a lot to memorize. But don't worry, the network pros have a trick for this. A simple little mnemonic to keep it all straight. All you have to remember is this phrase. All people seem to need data processing. See? Application, presentation, session, transport, network, data link, and physical. Pretty clever, right?
All right, so here's where it gets really interesting. The crucial part is understanding how your data actually travels through all these layers. So let's do this. Let's follow a single photo on its journey, from the moment you send it to when it arrives on your friend's screen. And to make it easy, we'll use a metaphor. Think of it like sending a package. Okay, so as your photo starts its journey down these layers, it goes through a really cool process called encapsulation. The best way to think about it is like one of those Russian nesting dolls. Each layer wraps the data in a new container, adding its own special instructions. So when it hits layer 4, it's called a segment. Then at layer 3, it gets an IP address slapped on, and boom, it's a packet. Then layer 2 adds a hardware address, turning it into a frame. And finally, at the very bottom, layer 1 takes that frame and turns it into a stream of ones and zeros, electrical signals ready to zip across the wire. It's this brilliant process that gets your photo all packed up and ready for its trip. Okay, let's pause for a second and zoom in on a really crucial step in that journey. We're going back up to layer 4, the transport layer, because right here, a super important decision gets made. How exactly is this package going to be sent? Basically, your computer has to pick between 2 different mail carriers. It can choose the super reliable one that guarantees delivery no matter what, or it can choose the super fast one that just cares about speed above all else. And this is where we see a fascinating trade-off, right? It's all about reliability versus speed. On one side, you've got TCP, Transmission Control Protocol. This is your tracked courier service. It does this thing called a 3-way handshake. It's literally a quick hello, hello back, okay, let's talk, to make sure the connection is solid before it sends a single thing. It guarantees every piece arrives safe and sound. That's why we use it for email or file transfers where you can't lose a single bit of data. But then you've got UDP, User Datagram Protocol. This is your postcard. You just drop it in the mail. It's way faster because it skips all those checks. And that makes it perfect for stuff like video streaming or online gaming, where if you miss one frame, it's not the end of the world, but lag is the real enemy. So you might be thinking, okay, this is interesting, but why does it actually matter to me? Well, it matters a lot because this layered model isn't just theory. It's an incredibly powerful tool for solving real-world network problems. Think about it. When your internet goes down, a network tech doesn't just start randomly guessing. No way. They use the OSI model like a logical roadmap. And a really common way to do it is to start at the bottom, at layer 1, the physical stuff, and just work their way up, layer by layer, until they find the problem. It's super efficient. They'll ask, is the cable plugged in? Are the lights on the router green? Okay, that's layer 1, the physical layer. Check. Then they move up. Is the IP address right? Can we even get out to the wider internet? That's a layer 3 problem. Is a firewall maybe blocking the connection? Now we're looking at layer 4. See how that works? This structured approach saves a ton of time, and it turns that vague complaint of the internet is down into a puzzle that can actually be solved.
So the next time you hop online, just take a second to remember these 7 layers working silently in the background. They're the invisible logical steps that took us from total networking chaos to the seamless communication we have today, connecting billions of devices all over the globe in a standardized, predictable way. And that brings us to a final, pretty interesting thought. The OSI model is, without a doubt, a foundational concept. It's the bedrock. But technology, as we all know, never, ever stops evolving. So it really makes you wonder, right? How does this blueprint, which was designed for a world of wires, adapt and apply to the wireless world we live in now, with Wi-Fi, 5G, and even satellite internet? That's all for this edition of The Explainer.